Good morning, everyone. Today we are discussing a differential equation. Today we are discussing the differential equation. So first of all, we have to learn the differential equation. So an equation, what is meant by an equation? Any expression which is equal to zero is said to be an equation. So differential equation means an equation involving derivatives. So with one dependent variable with respect to one or more independent variable. So before we have to learn what is independent variable and what is dependent variable. Here we are considering a line, so that is passing through an origin. So this is the equation with, so equation of a line which is passing through zero origin, that is 0 comma 0, that is origin. If you give the values for x, we get the values of y. So then x is said to be independent variable and y is said to be a dependent variable. If you give the values for x, that is x is equal to 1, we get y equal to 1m. If x equal to 2, we get y equal to 2m. So we are giving the values for x, we get the values for y. So x is independent, here y is dependent. So an equation containing derivatives, that is like this: d square y by second order, d square or d cube y by dx cube plus x into d square y by dx square plus 2 into dy by dx plus 3y is equal to 0. So this is the differential equation. See, this for any expression which is equal to 0 is we said to be equation. So in this equation, so there is a derivatives here. So and if we derivatives here. So here only one independent variable. So we can say that it has a more than one or more than independent variable. So here dependent variable is y and the independent variable also x. In this equation we are applying only one independent variable and one dependent variable. So this is the example for differential equation. Okay. And next types. Yeah, next one types. So here, so there are two types of a ordinary differential equation. One is ordinary differential equation, and other one is partial differential equation. Ordinary differential equation means an equation is said to be a ordinary if given equation and derivative differential equation contains only one independent variable. It is said to be ordinary differential equation. So that is example. So dy by dx plus sin x is equal to 2. This is also a one differential equation. So in next one is partial. A differential equation is said to be partial. So if the derivatives having containing two or more independent variables. So that is, suppose x into dou u by dou x plus y into dou u by dou y. Here the independent variable is 1, that is 2 u. Here the dependent variables is 2 here. So independent variable is u. Here we have two dependent variable, that is x and y. So that is equal to some u. So this is the partial differential equation. Okay. And next we will discuss the uh, next we will discuss the solution for this differential equations. Okay. So there are two types of a solutions. So one is general solution. One is general solution. So general solution means, so let us consider the differential equation x, a function of x, y dash, so on y power n, and the derivative is equal to 0. This is the differential equation. For this differential equation, we are finding a solution phi of x, y, and C1. These are the arbitrary constants, so on Cn. So this is the solution for this differential equation. So then here we are having n number of arbitrary solutions. For n number of derivatives, we have to we have the n number of arbitrary constants. So this is the general solution for given differential equation. And next one is particular solution. And next one is particular solution. So particular solution means a solution obtaining when we give the particular values for the given values. So if we give the values for x and y, we get the values for constant, that is c1, c2, so on, cn. So if we give the particular values to the arbitrary constant. So finally we get the values for the arbitrary constant. That solution is said to be a particular solution. Okay. So these are the basic concepts of the differential equation. So now we have so many methods to solve the differential equation. So one of the method we are discussing here is linear linear differential equation. So here the linear differential equation is here, linear differential equation is of the form dy by dx plus py is equal to q. Okay. So here P and Q are functions of x. Here P and Q are functions of x. For this linear differential equation, we have to write the solution. So solution is of the form y into integrating factor is equal to integral of q into integrating factor. This is the solution for solution for linear differential equation. But we have to know the what is the integrating factor. So here the integrating factor because every integrating factor means if we multiply some vector some value with a differential equation, it becomes a perfect difference. It becomes a difference. It can be integrated. It can be integrated. It can be solved. So that is the integrating factor. So here the integrating factor is e power integral p dx. So here e power integral p dx. Okay. We will explain one example of this linear differential equation. And other type of the linear differential equation is dx by dy plus px is equal to q. Okay, so p and q are functions of y here. Here p and q are functions of y. So the solution for this linear differential equation is x into integrating factor is equal to integral of q into integrating factor dy. So again, the integrating factor is e power integral p dy. So these are the two types of linear differential equations. So we will discuss one problem as an example for the linear differential equation. See, let us consider 1 plus x square, sorry, 1 plus x square into dy by dx plus 4xy is equal to 1 by 1 plus x square. Okay. And next, when we compare with the linear differential equation with dy by dx plus py is equal to q, see we all observe that there is no coefficient for dy by dx, so it has only one constant value, that is 1. So we have to divide here, there is a quotient, so we have to divide with that one. So we get dy by dx plus 4xy by 1 plus x square is equal to 1 by 1 plus x square whole square. Okay. Here p is 4x by 1 plus x square. Then q is 1 by 1 plus x square. We all observe that it is p and q are functions of x only. Okay. And we need to calculate the integrating factor. That is formula for integrating factor is e power integral pdx. So e power integral 4x by 1 plus x square. We need to solve the integration. So there is a formula. So that is f dash of x by f of x. If derivative for 1 plus x square, so derivative of 1 is 0, x square is 2x. So here in the numerator, we need to have a 2x. So we are right splitting 4 into 2 into 2. So we can write as 2 into 2x. So here the integral of f dash of x by f of x formula is log mod f of x. So log mod f of x. Okay. And we have 2 into log mod 1 plus x square here. Okay. So m log n means log n power m. So this is the formula. So we have log e power log 1 plus x square whole square. So already 1 and x square is the positive sum. We need no need to have the modulus value. So we are taking. So for every logarithm value, there is a base is e, and also the base is e. Here also base is the both the bases are equal. So we can write as 1 plus x square whole square. So here we find the integrating factor, and next we have to find the general solution. Here general solution is y into integrating factor is equal to q into integrating factor. So now substitute the integrating factor here, y into 1 plus x square whole square is equal to q. So what is q here? 1 by 1 plus x square whole square into integrating factor is 1 plus x square dx whole square. So 1 plus x square whole square, 1 plus x square whole square will get cancelled. We get 1 dx, that is x. Okay, integrating for x, 1 is x. Finally, we complete the integration. We have to keep the integration constant. So we get the solution y into 1 plus x square whole square equal to x plus c. This is the general solution for given differential equation. Okay. So in this video, we are discussing about the differential equation, types of differential equation, solution, and one type to solve the differential equation. Hope you all understand the theorem and problem. So thank you.